What's up everybody, Average Joe here, and welcome to another Average video. Alright, today's video is going to be video 2 of the residential energy storage system from BigBattery, which is basically the Ethos battery system and the Lux Power inverter. In video 1, if you missed it, all we did in that one was the quick unboxing. We went through all the specifications and the features, and then we actually installed it in my house right over there. So in today's video, video 2, what we're going to be doing is basically testing everything out. And obviously the best way that we can do that is to power my house. So without wasting too much of your time, I think what I'll do in this video, just in case you missed the last video, we'll do a quick little overview of the battery and the inverter, and then we're going to get right into the testing. Alrighty, so let's get to it. Alrighty, so what we have here is the 48 volt Ethos battery system, alright? These are the stackable modules right here. Each module is 100 amp hour or 5 kilowatt hour. So I've got 2 here, so that's 10 kilowatt hour. Over here on each side of the battery, underneath these removable covers, that's going to be where all of your battery connections are. And on the other side of the battery, there's a few different things. You're going to have your battery communication port, LED indicator, your power on and off button, and then there's going to be some dip switches over there so you can assign each battery a location so it can communicate with the controller unit right up here, and then the controller unit can communicate with the inverter. And speaking of the communication, this doesn't only communicate with the Lux Power inverter. There's already quite a few built-in communications, so you can use your own inverter that you might already have. So that's pretty cool. Also with the controller unit up here, I forgot to mention there's a little tiny screen up here which is going to give you some basic battery information. That's going to be your battery voltage, your state of charge, capacity, and then of course the communication protocol that you set up in here to communicate with your inverter. And then finally, one last thing for the controller is you can actually parallel up to 16 more batteries for 81.9 kilowatt hour worth of battery storage. And if for some reason you think you need more than that, you can just parallel in another controller unit and then of course add batteries from there. And then finally, what makes this so badass is it is UL certified, okay? So it comes with a couple different certifications. The first one's going to be the UN 38.3, second one's going to be the UL 1973, and the third one is going to be the UL 9540A. So what that means for us is this is 100% safe to install indoors and outdoors in your home in all 50 states. And not only is this safe for your home or residential use, you can use it in a industrial or a commercial property or installation. And then a couple last things is this was super easy to install. Basically, it comes with a battery base. You're going to stack all of your batteries on top of that for however many batteries you have, and then finally install your controller unit on top. There's also a couple of brackets on the side that connect everything together and to the wall so it can't fall over. I'm not going to show you that in this video. That's going to be in a whole nother video. I'm just going to do a whole installation video. So if you want to see that, make sure you hit the subscribe button and come back to watch that. And then I'm actually going to do a third video for an example, as if you bought a 10 kilowatt hour system just like this. Later on down the road, you find out it's not enough and you want to add more. You can do that because this is a stackable system. I have another battery sitting right over here just for that. Okay, and then finally, this also comes with a 10-year warranty, and if you're not aware, BigBattery is here in the United States. All right, that's enough of the battery. Let's check out the inverter. All right, so now on to the inverter. So this is the Lux Power 12,000 watt, 240 volt split phase hybrid inverter. Hybrid inverter, all that means is you can push and pull from the grid, if you have a grid tie system. However, you can also use this as an off-grid inverter, which is a little bit more my style. And just a little quick note is we're not going to be doing any sort of backfeeding to the grid in this video. Anyway, I was just going to run over some of the specifications, features, and stuff that you can do with this, and there's a few different ways that you can hook it up. So we'll start with those first. So option 1 is a whole home backup. That's basically whenever you install this after your utility meter outside, okay? And then you run it into your main panel, and that's going to cover your entire house. And also with the whole home backup option is this has the capability to pass through your 200 amp service, okay? That just means pass through. Just remember, this is only a 12,000 watt inverter. It can only create 12,000 watts. I think people get a little confused on that. The second option is going to be a partial home home backup, which is what I'm going to be doing. Basically, I'm going to be coming off of my main panel, feeding the inverter, and then on the output, I'm going to be feeding another sub panel. That's what a partial home backup is. The only reason I do that for right now is off my main panel, I have my stove, air conditioning, and dryer. In an emergency situation, I'm not too concerned about running those really big loads. And also what makes this really badass, since it is a hybrid inverter and you can backfeed, this has an option in here where you can not backfeed the grid. It'll actually backfeed my main panel, so I'll still be powering my stove, air conditioning, and dryer. If the grid goes out, it's not going to power the main panel, it's only going to power the sub panel. Just like I said, I'm not too concerned about powering the big load items, you know, in a real power outage, because you're going to need some battery capacity to keep that going. Anyway, back to the badassery of the inverter. So you can install up to 18,000 watts worth of solar, hence 18 kPV. Technically, you can go over that, but you're only going to be able to use 18,000 watts. Solar input is 150 volts up to 500 volts. It's got dark start mode, batteryless mode. It's got an integrated UPS module inside for seamlessly switching on and off grid. You can do smart load control. You can actually use your existing AC coupled solar system going through the generator input port. It has a generator input port. It can do peak shaving. You can parallel in another inverter. So if 12,000 watts isn't enough, you can always add more. It's got built-in RSD. It's got your solar PV disconnect switch right over here. And then right below that, it's got an RSD off button, which basically shuts down the entire system. There's so much stuff that you can do with this. I'm sure I'm leaving out quite a few things. All right, so that's enough of the inverter. Let's start powering my house. Alrighty, so the rest of this video is probably going to be real similar how I've tested other systems and my system in the past. Basically what we're going to do is switch this over to power my entire house, and then we're going to throw a whole bunch of loads at it. Some of those loads are going to include my air conditioning, my stove, and my dryer. And also keep in mind, I'm not going to keep the air conditioning running for very long because it's wintertime and it's like 30 degrees outside. So we'll start it up, we'll let it run for, I don't know, a little bit of time, and then I'm just going to shut it right off. And I think today is supposed to be a pretty good day for sunshine, so we should get a lot of solar today, and we can kind of put this through its paces. All right, to get this party started, we're going to go back to my main panel and switch over my transfer switch so we can switch over to the Ethos and the Lux Power system. Alrighty, so in my house, I've got a transfer switch right here. The bottom side, source B, is the grid, and source A is going to be the Ethos and the Lux Power system. Once I flip this over, we might see a little bit of a blink, but that's just me switching it over. All right, here we go. Now we're powering the house off of the Ethos battery and the 12K Lux Power inverter, and of course, whatever solar we have coming in right now, which may be 400 watts. Let me bring you closer into the screen and you can see exactly what's happening. All right, so we are gonna note the time right up here. It is basically 10:10 a.m. So that's roughly when we started this test. You can see solar panels up here, inverter right there, battery right here, and then my house or the loads right here. And then finally grid is going to be right over here. So at this current moment, we are charging with solar. So array 3 has 336 watts, array 2 has 67, and array 1 has 53 watts. So from there we come down to the inverter, and we're actually pulling from the battery, and my house is drawing, we'll just basically say 1100 watts, because that's going to change, of course. Alright, so that is my entire house. Even though I'm technically only powering a sub panel, since this is a hybrid inverter, it'll backfeed the main panel. However, it'll stop at those CT clamps that we installed, so we won't backfeed into the grid. So that's pretty awesome. If you want me to go over to the settings menu, I can go through this real quick, but we definitely have the zero export checked, all right, because we do not want to export back to the grid. Go down to charge. I'm using the state of charge settings in here. This is if I wanted to recharge from the grid, okay? And then for my discharge setting, again, I'm using state of charge. On-grid cutoff is at 15%, and then off-grid cutoff is 10%. So these settings right here is if we're off-grid like we are right now and the batteries reach 15%. That means we're going to switch back to grid so we don't discharge past 15%. You can set that whatever you want. And then this setting over here is very, very similar. However, if we reach 10%, it'll shut off the loads, all right? Basically, it'll shut off the house. and keep powering the inverter from the battery. That's basically there to prevent you from discharging the battery all the way down to 0. And then down here, I don't think I have anything else set because I'm not going to be doing grid peak shaving, smart loads. I'm not going to be doing any of that stuff. If we go into advanced for my PV, since I've got 3 separate arrays, I've got PV1, PV2, PV3, and independent right up there. Most of these settings were already set in here. I didn't have to change any of that, okay? I did check off-grid output and seamless switch. And that's basically if the grid goes out, it's going to seamlessly switch to the inverter and batteries, all right? You shouldn't have a delay of any sort right there. All right, and you got a bunch of other settings in here that you can change. I haven't changed anything else in here. We go back to the battery type and battery brand. Both of those are going to be lithium 2. And then down here, I didn't do anything down here. And then you got debug info and then device info. Currently, the build or firmware that I'm running is the Fab 1717. All right, that's just a quick little overview of the screen and all the settings that I'm using and how everything works on there. Again, they do have the Lux Power app. Just keep in mind that the Lux Power app, it doesn't refresh very quick. So during this video, I'm going to be using Solar Assist. That's only because it'll give me information quicker. Other than that, the Lux Power app works fantastic. All right, typically what I do next is I go around my entire house to show you what is being powered. And then after that, we're going to throw some big loads on it. All right, one of those loads, I'm actually going to do a whole load of laundry. I'm going to do the washing cycle and the drying cycle. Also during this test, over here, I do have a sound meter or SBL meter. I have a thermal gun right here. And then finally, I have a voltmeter, which we can test voltage if we need to. And we can also test amp ratings, okay? All right, let's get to it. All right, so back here in my dirty shop area, I've got a couple lights up there. Those are all LED. I've got an LED light up there, and then my whole computer system right here. Got 2 LEDs right up here, which are above the inverter. I got a couple more LED lights on down here. Of course, we have the important beer fridge right here. On the stairs, we have 3 LED lights right up there, 1 at the top of the stairs. In the kitchen, we've only got 2 of the pendant lights on right now. And then upstairs, we also have our regular refrigerator. We got a wirelessly powered cat right there, cat drinking fountain right there, air filter thingy right there. We got 2 LED lights on back there, and in the bedroom, of course, we have our alarm clocks. The furnace is on. It's 38 degrees out, by the way. And in the TV room, we got the 2 LED lights over there. We got 1 right there, and then, of course, we have our cable modem, router, and all of that fun stuff right down there. Another battery powered cat right here, the other one right over here, and that's everything that we have powered in the house currently. All right, so next thing we'll do is we'll take a look at the Solar Assist app. If you look over here on the left-hand side where it says load, that's going to be our house. So we're drawing 948 watts roughly. To the right of that, that's going to be our solar input. And then right below that is how much we're drawing from the battery right now. And that's only around 411 watts. And then finally on the lower left is the grid. And as you can see, we're not drawing from the grid. All right, first thing we're going to do right now is start the washing machine. Drop in all the clothes. All right, washing machine is on. It's not really doing a whole lot, so we'll come back here in a little bit when it's actually doing something. And I can hear my furnace getting ready to kick on too. Now the furnace has kicked on and we're up to 1,350 watts. Not a whole lot. Alrighty, I went around and turned on basically every single light that I could find. So we have over 54 lights on. A majority of those are LED. We have 2 refrigerators on. You know, we're powering the entire house. We have the washing machine running. If you look at the app right here, the house is drawing basically 2,000 watts, which is nothing, okay? 1,620 of those watts are being drawn directly from the battery. All right, simulated pot of coffee time. So we'll fill this up to 12 cups. All right, we got our 12 cups of water. Let's make some simulated coffee. All right, here we go. Boom, jumped up to a little over 3,200 watts. That's total for the house. And then for our battery power, it's almost 3,000 watts. And our solar right now is 605 watts. All right, I'll let this go and I'll be right back. All right, coffee pot is still going. We're gonna step back in time real quick and we're gonna heat something up in my microwave. This is pastrami and Swiss. We're gonna turn that on for a little over 1 minute. Here we go. All right, so now we're up to 4,500 watts. Battery is drawing 4,130 watts. All right, that looked like it worked out pretty good. Now we drop back down to 3,000, basically 500. Battery draw is 3,000. All right, and then right up here, I forgot to mention, is our battery information. So our voltage right now is 52.3, and we're dropped down to 89% so far. Boom, coffee is done. So now we're sitting at 52.7 volts. Battery state of charge is at 88%. Our house load right now is 2,140 watts. Battery is 1,433 watts. That's basically because the solar is offsetting it a little bit. Solar right now is 784 watts. Not bad. Yum. All right, washing machine is done. We're gonna go ahead and throw it in the dryer. And I'm gonna do a timed dry on basically the highest heat. We'll do 50 minutes. All right, here we go. There was no dimming of the lights. Okay, so now we're drawing 7,000 watts from the battery. Our house load is 8,000 watts. Solar PV is 2,000 watts. All right, well that's a pretty big load. Let's go see if the fans are turned on the inverter. And if it is, we'll take a sound measurement. Alrighty, back over here at the inverter. We're running my entire house, which includes, over 54 lights, 2 refrigerators, my computer system over there, and we also just turned on the dryer. So I don't know if you can hear it from my microphone right now, but the fans are turned on. So I'm standing, I don't know, 3 feet away. All right, and then we're actually gonna do the sound test. All right, so from right here, all right, I figured out how to turn the light on. So I would say an average of 60 decibels. All right, next we'll take some thermal readings, and hopefully this shows up on the camera okay, but we'll start with the battery cables first. Positive battery cable is 80 degrees. Negative battery cable, 82 degrees. If we go over to the house wires, those are basically 75. Go to the backfeed wires or the grid input wires, those are 77. All right, so everything in here is nice and cool. All right, if we want to take a look at the battery, everything in here is 77 degrees. Yeah, hottest spot is 77 degrees. The next thing I want to do while all this is running is see if we can start a 4-ton air conditioning. All right, so my 4-ton air conditioning does have a soft start. I would imagine it's going to start up real easy, but hey, you never know. There it goes. I was waiting for the dryer heating element to turn on. All right, so we're gonna turn on the air conditioning. So we're drawing 5,800 watts from the battery. My house is drawing 7,700 watts. All right, here we go. Flip that over. It should turn on any second. All right, there's an 8,000 watt load. 9,000 watt load. 8,000 from the batteries. 10,000 watt load, 10,500, almost 9,000 watts from the battery. Nice. All right, so I'm pretty happy right now. This is amazing. I've never actually been able to do this ever. Boom. Drying is complete. So we were able to complete 1 full cycle on the washing machine and the dryer, no problem. All right, next thing we're gonna do real quick while we're down here is we're going to turn off the grid power and go into basically battery backup power and only power the sub panel, just to give you an example of how that works. Also during this test, I'm gonna set up a camera over by my computer system to make sure it doesn't turn off or anything like that, just to show that it does have a seamless switch. All right, so this is gonna be my sink. All right, camera is set up over there. All we're gonna do is open up my main panel right up here and flip off the main breaker right here. All right, here we go. All right, there was just the littlest flicker right over here. You could see in the lights. All right, so it looks like everything over here stayed on, so that is fan-freaking-tastic. All right, so that worked out pretty good. So basically what's happening is we're not powering anything in this panel right here. We're only powering everything that is on this panel. All right, I just want to show you real quick what happens on the inverter screen. All right, so grid power went away. We do get a little notice right here or a warning. That's basically because the grid power went away, okay? So right now we're still using solar and battery to power the EPS or UPS load, okay? So we're still drawing 1,978 watts. And the only thing we're not powering is the main panel, which is over here on this little house symbol right here, okay? So if the power ever goes out, this is what it's going to look like. So what I'm gonna do real quick is I'm gonna go flip the main breaker back on. However, I'll just leave it on this screen so you can see what happens. All right, main breaker back on. Okay. A little tiny click and flash. Now that we have a stable connection from the grid, we go back into the self-consumption mode. So we're powering from solar and battery and powering my entire house. All right, next test is gonna be powering the stove. So real quick, the time now is 1:13. We've actually been running for a little over 3 hours. Battery voltage is 53.2 volts. We're at 61% state of charge. House load is 1,892 watts. We're actually recharging the battery at 800 to 1,300 watts, and that's because of solar. So basically, we're gonna start with this big burner first. We're just gonna go straight to high. And waiting for it to update, and we're drawing 2,000 watts from the battery. All right, that ain't bad. We're gonna go for this big burner right here, straight to high. All right, boom, there we go. So now we're drawing 8,000 watts on the house. Battery is drawing 5,332 watts. So we'll do one more burner right back here. I haven't seen it update yet. We're still drawing, there we go, 9,600 watts. All right, we're gonna go for this burner over here. Ooh, 11,160 watt load. Almost 9,000 watts from the battery. Nice. 4 burners, no problem. 11,000 watts from the load, and the battery is almost 9,000 watts. All right, so I'm gonna turn these off, and then we're gonna turn on the ovens down below. We'll just go 350. Start. Okay, we're going to turn on the lower oven. We'll do the same thing, 350. Start. Okay, now we're up to 7,300 watts over here, and we're drawing 4,500 watts from the battery. Keep in mind, we also have 3,300 watts of solar coming in. All right, so I've got both double ovens on, and we're going to turn on that burner right there. Let's see what we got. 11,400 watts, almost 9,000 watts from the battery. Nice. There's a few lights that I missed. I think we're close to 60 lights, by the way. All right, so it looks like you can power the double ovens and at least one of the burners up here, no problem. Alrighty, so at this current point in time, which is 1:29 p.m., I went around and turned off all the unnecessary loads because right now I'm going to try to recharge before the end of the night, basically, or the end of the day. So my house load is back down to 920 watts. We're bringing in 3,310 watts of solar, and we are recharging the battery at 2,336 watts. I don't know if we're actually going to get full charge by the end of the day, but we're going to give it a go. Quick little update. Time now is 3:27 p.m. and look at that, 98% state of charge. We were able to recharge off of solar while running my house and mainly my computer stuff back there. But anyway, what we have right now is our load. Our house load is 953 watts. We're recharging the battery at 1,600 watts, and we have 2,600 watts of solar coming in to recharge my house and power my loads. We have 0 grid coming in. So far we're doing absolutely fan-freaking-tastic. I mean, I couldn't be more happy right now. All right, so the next question most likely is going to be is how long will a 10 kilowatt hour battery last? We're going to test that out for the rest of the day, and hopefully through the night we're going to power my house off of the Ethos battery. If the battery dies, of course, it's automatically going to switch over to the grid or pull from the grid as necessary, okay? So you're not gonna lose power or anything like that. So that's what we're gonna find out for the rest of the video. I'll probably just check in randomly and give you updates on battery percentages and all of that kind of fun stuff. No, we didn't, but we made it real close. We made it until 4:30 a.m. And I'll show you all that in the solar assist, screenshot right here. All right, so we started our test roughly 10 a.m. yesterday when we flipped everything over and started powering my house. That's going to be all the way on the left-hand side. Right below that is going to be a little tiny legend, and it shows blue is my house load, red is the grid, and yellow is solar. First little spike area is going to be the coffee pot and microwave time frame. Noon time was basically the dryer and the air conditioning and stuff like that, and then probably 1:15ish was the stove test. And then the rest of the day was just powering everything as we normally would. We didn't try to conserve anything. We didn't try to do anything extra. It was just a regular average day. All the little spikes that you see from then on, I'm pretty sure is basically whenever my furnace would kick on for a little bit of time and then it would shut off. That's basically what all of those represent. And then about 4:30 a.m. we hit the 15% state of charge, which we have programmed into the inverter, and then we went back on grid, or we started pulling from the grid as needed. And then that only lasted for another 4 hours and 15 minutes or thereabouts to roughly 8:45, and then we went off grid, which we are still off grid at the current moment. So basically during that entire test from start to finish, we lasted a little over 18 hours, which I would say is honestly pretty good with a 10 kilowatt hour battery. Yes, we do have some solar connected and we were using that, but I wanted to test this, like we would on a normal day. And actually, if I would have started the test sooner in the day, at like 6 a.m., then we could have gotten just a few more hours off grid. But overall, I don't think we did too bad. And now that I'm thinking about it, the other battery that we have over there, the 5 kilowatt hour battery, once we get that installed, we should be able to last the entire night. But of course, we'll see. And there is one other little thing I want to mention real quick back on the Solar Assist screenshot. If you notice down here in the red for the grid, you can see all the little spikes basically go up whenever I turned on a really big load. That's what this inverter does if you have the grid connected. Hybrid inverter type stuff. So that's what this does is basically, you're still pulling from the grid, but you're using battery power to feed the inverter, which pushes the grid back. And then let's say you turn on a really big load, it sucks that power. Think of it as a capacitor. That energy gets pulled out real quick, but the grid is there, so it fills the gap. And then once the capacitor recharges, it pushes the grid back down to zero or back to the CT clamps. In our case. That's basically what it does. And as you can tell, we didn't really feed back into the grid. I think occasionally it'll flick on a little bit and then it'll turn back off. That's that fast zero export. Hybrid stuff. And there's actually one other thing I need to clarify is I kind of lied but kind of didn't. Yesterday, whenever I was running the stove and air conditioning, whenever I said I've basically never done that before. It's kind of a lie, but it's kind of not, and I'll explain a little bit. So in my last system using the grow watt inverter, the 12,000 watt grow watt inverter, it's all hooked up the exact same thing. The inverter output is powering my sub panel over there. The grow watt cannot backfeed my main panel, which has my stove, air conditioning, and dryer on it. However, last year I did install a generator lockout on my main panel. A generator lockout is basically if you want to run your house off of a gas or diesel generator during a grid outage or, whenever you want, basically. I installed one of those on my main panel and then installed the inverter output onto that circuit breaker right there. So basically you shut off the grid and then turn on that breaker so then I could power my entire house. During that time, I can power, the stove, air conditioning, and dryer. However, during the summertime, our air conditioning runs a lot. I basically run out of power at like 2 or 3 a.m. because the air conditioning runs so much. So since I disconnected the grid at like 2 or 3 o'clock in the morning, we were literally out of power. I had to come back down here and switch everything back over. So it's kind of a lie, but kind of not that I couldn't power all those things before, which I technically could. I really only did it a handful of times, just testing stuff out. So it was kind of a lie, but kind of not. The way this inverter works is I'm still powering my sub panel. However, this will backfeed my main panel, but stop at those 2 CT clamps. I'm able to power my stove, air conditioning, and dryer. you know, as long as we have solar and battery power. If the sun goes down and the batteries die, I'm still able to pull from the grid, which the Grow Watt could not do. So that's my explanation of why I'm really excited with this inverter, because I can leave everything the same. Technically, I don't even need my sub panel anymore, and I can still power everything in my entire house. So that is really exciting to me. All right, well, that's pretty much all I got. I didn't want to waste too much more of your time because I'm sure this video has gone on long enough. So if anybody has any questions, comments, or concerns, definitely put those down in the comment section. If anybody's looking for a badass UL certified system that you can start your on-grid or off-grid journey, Big Battery gave me a 10% off discount code, which is Joe10, so you can save some cash if you want. You don't have to. And again, I'm not going to tell you guys whether you should or shouldn't buy the system because, you know, that's going to be completely up to you guys. You guys are big boys and girls. You're going to have to decide that for yourself. But what I will tell you is you will not be disappointed. Are you done playing with the bag? Cats and bags. What I was going to say is you guys will not be disappointed with this setup right here. So if anybody thought this video was helpful in any way, it would be really appreciated if you like that smash button on your way out. And of course, don't forget to subscribe and come back for video 3 where we're going to install that last 5 kilowatt hour battery, or if you want to see any of my other battery and inverter videos. That's pretty much all I got, and I'll see you on the next one. So that means it is 100% safe. And then you get a free pallet to make whatever you want.